Hello, welcome everyone. Thank you for joining us at today's webinar. This is Dave. I'm the moderator of this webinar. We are pleased to have the Innotec Engineering and Coltraco Ultrasonic here with us. Today, we have 5 speakers. Mr. Simon Zheng and Edmund Law from Innotec Engineering, Mr. Daniel Bobowski, Mr. Bernard Honan, and Angus Hawkins from Coltraco Ultrasonic, sharing on the topic of the world's first innovative technology using ultrasonic to detect, locate, and quantify leakage for the COVID-19 ward room and the clean fire agents protected premises. The speaker will introduce how to use this innovative ultrasonic technology to address the challenges that are often encountered in the built environment and healthcare sectors. So if you have any question during the presentation, please type them in the question box, and we will have the Q&A session at the end to answer all the questions. So before we start the webinar, I would like to invite all the speakers to turn on the camera to have a snapshot of the photo. Can you all speakers turn on the camera first? Thank you. Okay, 1, 2, 3. Thank you, everyone. So without further ado, I will hand it over to Simon to start the presentation. Thank you, Simon.
Thank you, Dave. Good afternoon, everybody. Is my voice okay? Okay. While we are, can you turn to the page? Okay. While we are facing the problems of COVID-19 in past 2 years, engineers may have worked on the solution in reducing the risk and improve working environment by means of filters and ventilation systems. A December 2020 studies on COVID-19 and air contaminants indicated that 56% of the air samples taken from hotels hallway and 24% from hospital bathrooms have high level of coronavirus. A study reported that air samples from ICU rooms were more than twice likely to be positive. The study found SARS particles will circulate in the air within 25% in ICUs, compared to 10% for non-ICU rooms. Precise leakage detection systems able to locate and then quantify the leak may be one of the solutions for hospital wards, clean rooms, and sterilization departments. Building Service Research and Information Associations, BSRIA, released a guideline on air permeable test of isolation facility, BST3 in 2018. BSIRI suggests the test method and specify the requirements of air permissible for an isolation facilities. Regular but not interrupted maintenance. Tests of the air leakage rates of the facility is a challenge for both the operation and service team, so as to meet the stringent demands of 365 days, 24 hours of service. Okay, carbon dioxide, halon, clean agent, and air inert gas extinction systems are commonly adopted in Hong Kong for facilities such as data centers, switch rooms, or other electrical hazardous areas. The effectiveness of the extinction system depends very much on the concentration of the extinction media and the hold time provided. In March 2019, Mr. Andrew Ender, chairman of Working Group Gas, Fire Industrial Associations, FIA, stated that the overall integrity of the system is vital. Important and many factors include the designs of system, the quality of the installation, the testing of the pipe that carry the gas, and the integrity of the protection rooms methods, greatly to the overall effectiveness of the system. National Fire Protection Association, the NFPA, 2001 code, Standard on Clean Agent Extinguishing System, under Chapter 7.5, the approval of the installation. The review of the room integrity course stated a quantitative result shall be obtained and recorded using an unapproved blower fan test or other means as approval. Guiding notes and procedures on the room integrity test will provide by Fire Industrial Association and under NFPA course NSC. After the integration test or the blower fan test, a report showing the leakage area on the design pressure per manufacturer recommendations will be recorded and generated. In this year, Hong Kong Fire Service Department issued a circular letter 1/2022 requiring fire service contractors, the FSIC, to submit the room integrity test together with the Form 501 for new buildings and together with the 314A for new buildings in occupied premises. The circular letter was effective from August this month for a trial period of 2 years. When the procedure started, a database will be formed and to record the leakage permitted for each gas extinguishing room for the industry. The service contractors is responsible to verify that no alteration and additional work, which may affect the room integrity when they carry out the annual inspection for the gas system. And they shall fill in the declaration forms and endorsed by owner and occupiers. The service contractor needs to plan ahead and work out with occupants and owners on how to verify the enclosure integrity during their operations on annual basis, while their operation are also works around the clock in 365 days, 20 hours a year. The global transition to a zero carbon method of design and construction is one of the primary objectives on business, government, and society today. Any unwanted air infiltration or leakage through gaps or cracks in the buildings will adversely affect the integrity of any filtration or purification process, as well as increase the energy consumption of air handling units. Air permeable regulations are implemented in UK buildings and construction industry. When there's air tightness of the rooms and buildings must be regulated to ensure sufficient of ventilation, energy, performance, and protect against fire. As more and more moderate integrated construction approach is applied, designer is facing difficulty in identifying the location of air or water leakage after final assembly of the modules. Mechanical and electrical installations with price and ductwork are construction in modules. Site acceptance test is one of the key elements before final testing and commissioning. Integrating tests on building element and MEP surface is a problem we are facing. It includes the rectifications on design assumption during the on-site tests, labor and time consumption to identify the exact location of leakage during the integration test. We hope the ultrasonic leakage detection system can be one of the instruments to support us by providing not just a qualitative, but also a quantitative measure so that we can identify and locate the leakage of the area for our industry. This is the end of my presentation. I think it brings along our challenge to the industries. I let the area to Daniel. Thank you.
Thank you very much, Simon, for that great start to the presentation. Hello, everybody, and thank you for joining the webinar. My name is Daniel Dobrowolski. I'm the Senior Physicist at Coltraco Ultrasonics and the head of the Durham Institute of Research, Development and Invention. Crucially for this presentation, I was also the lead developer of the Portascanner AIRTIGHT, and I'll be talking through today some of the technical details about the instrument, the advantages of it, before we move on to a few case studies and applications. Next slide, please. So first of all, before I go into the instrument, I'll talk very briefly about Coltraco Ultrasonics, the company that we work for. So Coltraco is based in London, although we operate globally in over 120 different countries, and we operate over a diverse array of market sectors, 25 in total. The organization consists of the company itself, our laboratory, which is based alongside the Center for Advanced Instrumentation at Durham University in the UK, and our research organizations, which are the Durham Institute of Research, Development and Invention and the Center for Underwater Acoustic Analysis. We are engaged not only in the manufacture of advanced instrumentation and systems, but also the research, design, and development of those systems and instruments. We, through our work with Durham University, are keen to identify and nurture brilliant young minds, whether they be in a variety of disciplines across the sciences and indeed elsewhere. At DURDI, our institute, we undertake fundamental research into the physical laws of the universe alongside our applied research in a number of fields, including mathematics, engineering, physics, and computer science, and more specifically in acoustics, electromagnetism, and information engineering. We deliver genuine value for our customers through our scientific and institutional values and the global quality of our commercial and technical services. And hopefully this will shine through today for you as I talk about our product, the Portascanner AIRTIGHT. Next slide, please. So as a company, we've been operating for many years now, since 1987. And for many, many years, we've been operating both in the fire sector and the marine and naval sectors. During our long history in watertight integrity monitoring for the Royal Navy, we've always known that it's one thing to identify and locate leaks ultrasonically, but quite another to be able to quantify those leaks. For many years, we've been wondering how to solve this problem, and none of our competitors, or indeed ourselves, have been able to do it until very, very recently. In fact, it was 2020, with the onset of the COVID-19 pandemic, when we were able to tackle this problem head-on as a result of the UK government's COVID-19 emergency response grant. We were given this grant in order to develop a technology which would help our National Health Service, the NHS. And through the grant, we were able to develop what became the Portascanner COVID-19, which was specifically designed to measure the routes of airborne infection spread in NHS hospital ICU wards. That enabled those wards to be effectively negatively pressurized to contain the disease. From the Portascanner COVID-19, we then went on to create the Portascanner AIRTIGHT. The Portascanner AIRTIGHT contains all of the capabilities related to airtightness. So that includes the prevention of contagious diseases spreading through airborne routes, the specification of ventilation in buildings, the assurance of thermal comfort, thermal insulation and acoustic insulation, thereby enabling surveyors to facilitate the achievement of net zero carbon emissions. And of course, fire safety, using the instrument to guarantee the required level of airtightness to ensure that an enclosure can contain the gaseous suppression systems needed to extinguish a fire. So our research has resulted ultimately in an instrument that is the first of its kind, a British handheld portable analytical instrument, which can complement existing airtightness testing, such as the door fan test or pulse test, or in some cases act as a replacement when those tests are ineffective or impossible to use. Next slide, please. So what are the advantages of the Portascanner AIRTIGHT 520? Well, first of all, it is a very quick and effective way of locating leaks. So you can know exactly where those leaks are within a structure, whether it be a wall or a door seal or a window. And it also quantifies them, meaning that you can know how significant they are, whether they need to be sealed or whether perhaps they don't. It enables you to provide evidence of your maintenance program, to locate, quantify, and record leaks all in one instrument. And it enables you to improve the efficiency and quality of your airtight room maintenance. It's a quick, easy to use instrument that can be used effectively by a single person. It's a very accurate instrument. It determines air leakage rates through walls, doors, and seals. And it calculates the number of leaks, the leak area of each leak, the total airflow rate, and the air permeability rate for a room or building. It's precise. It can accurately identify leaks, so remedial measures can be taken, and it can detect leaks as small as 0.06 millimeters in diameter. We have also verified the accuracy to be greater than 90% for the quantification of leaks between 0.5 and 10 millimeters in diameter. And you will see on the next slide exactly how we achieved this. So as well as our in-house laboratory testing up in Durham at our laboratory facilities there alongside the university, we were also able to verify this independently through our work with the National Physical Laboratory, which is an institution in the United Kingdom, which is our foremost measurements and standards institute. You can see here on the left a photo of their semi-anechoic chamber, which is where we conducted all of our tests. And the scientists at the National Physical Laboratory were able to investigate our instrumentation using a motorized alignment measurement system and to investigate our algorithm, which we developed, and compare it to the results that they achieved. Specifically, the algorithm that we developed was the first of its kind, a theoretical algorithm that we had then backed up with empirical evidence. And that related the amplitude and various pieces of data about the ultrasound that is received by the unit to the cross-sectional area of the leaks through which the ultrasound propagates. And you can see here from the graph that the results that NPL got were very, very similar to the predictions that we had made. Indeed, in this instance, the measured values differed by at most 5% from the true value. Next slide, please. Now, this is a video of a diagram animation of the operation of the unit. So if we can just play that. So on the left-hand side, we have a generator, and on the right-hand side, there is a receiver. And you can see that as the wand moves towards the point of leakage, on the receiver, there is a red bar which moves up, indicating the presence of ultrasound and thereby a leak. And you can see there is also a pair of headphones that the user may wear, and those will beep whenever the wand passes over a leak. So what is happening physically here is that ultrasound, which is a very high frequency sound wave, is propagating through the air from a generator towards a material. If there are no leaks in that material, then the ultrasound will reflect off of that material and no significant amount will propagate through it. However, if there is an air leak in it, no matter how small, indeed, as mentioned earlier, we can detect as small as 0.06 millimeter leaks. Some of that ultrasound will be able to propagate through. Now, as it propagates through the leak, it will become diffracted, meaning the waves will spread out. Also, as the waves move through the air, they undergo something called geometric spreading, where the amplitude and, well, the intensity indeed, over time is reduced. So with that physical understanding of the behavior of waves, we were able to inform an equation which ultimately led to the quantification which we have in the unit today. Next slide, please. All of this is automatically calculated. And the device is navigated with an easy to use touchscreen interface. And you can see here one of the screens on the device where a photograph of the area being tested has been taken, leaks have been marked, and the data about the leaks have been calculated, including the cross-sectional area in square millimeters and the flow rate in cubic meters of air per hour. We'll see a little bit more about this later. Next slide, please. Once a test has been conducted, the device generates automatically a report for each test. That report can be in the form of a PDF or in a more simple form as an Excel CSV spreadsheet. This is an example of a PDF report. So at the start, we have the title of the report, which contains information about the site that you're testing and the particular house or building, as well as the date. Then we have a sort of summary page. Now this page tells you a value for the air permeability of that house in this instance, as well as the air changes per hour, which can be a useful metric for understanding how much air is going to move in and out of that space over a certain period of time. Each succeeding page after that summary page will show one of the structures that has been tested. In the first instance, it's the main door of the house that we tested here. This was in fact a facility within the AirTightness Testing Measurement Association, which we will talk a little more about later. But you can see here that there is a photograph that was taken using the built-in camera within the instrument of the door. And on that photograph, the user has marked a number of leaks that they've detected. Those leaks are numbered, and the values for those leaks are listed in the table below. Each leak corresponds to a certain cross-sectional area and a certain airflow rate. And at the bottom, we have the totals of those values. Next slide, please. Here are some more pages from that report. So as well as the door, we tested a front panel of the house and a window and an area of roof. And you can see in all of these locations, we found leaks, some of them incredibly small leaks, but leaks nonetheless. So we were able to assess just how leaky these areas were and whether they needed any remedial action. Next slide, please. Specifically, how can we use the Portascanner AIRTIGHT 520? Well, there are a number of ways we can use it. First of all, you'll probably be familiar with pressurization tests. We have the door fan blower test, and also a newer technology called the pulse test. It can be used before these tests to make sure that they pass first time, every time. So rather than having to go through the effort of setting up a door fan blower test multiple times to try and get a structure to pass, in this instance, you can locate easy to spot leaks, first of all, quickly and effectively, seal them, and therefore ensure that when you do go through the hassle of pressurizing a space, it's going to pass. Secondly, it can be used alongside a door fan test. When you're pressurizing a room and you're trying to assess the air changes per hour, you will notice that there are some areas where airflow is escaping quicker or more obviously than others. And this tool, the Portascanner AIRTIGHT, is very, very good at locating those areas quickly and actually quantifying scientifically how important they are. And then finally, as you will know from the regulations, you can't just test one space once and leave it forever. It's important to test spaces regularly, year after year, because buildings are dynamic objects. They change with weather events, high winds, temperature changes, spaces will change, leaks will emerge where perhaps they didn't exist before, and therefore it's very important to regularly test once that initial pressurization test has occurred. And the Portascanner AIRTIGHT is a great unit for doing that because it's non-invasive and can be used when the building is being used for its usual day-to-day purposes. Next slide, please. Now I'm going to pass on to my colleague Bernard Hornung, who will talk a little bit about some of the applications of the Portascanner AIRTIGHT.
Good afternoon, and thank you very much indeed, Daniel. I'm Bernard Hornung, and I joined Coltraco just over 2 years ago after a 30-year career in real estate, and specifically being a resort property developer. Building physics and airtightness. The art and science of building physics is a term that describes an understanding of how buildings respond to moisture, heat, cold, light, and air movement within the building. The common denominators in enhancing building performance include both thermal insulation and airtightness, without which you cannot effectively control the indoor environment or achieve a level of human air hygiene to ensure safe working and living conditions. It is not acceptable to enter a building, particularly a hospital or healthcare center, and to be infected in this process, when we have the means and the technology to prevent this. We have the technology to increase air changes per hour in a room or building to ensure better human air hygiene. However, this will mean more air being pushed through finer filters more frequently. Natural ventilation. Natural ventilation is by far the most ordinary form of room decontamination worldwide. However, it has its limitations. Doors, windows, and other apertures are often closed in inclement weather, and wind currents are not always conducive to good air exchange within buildings. Extreme air pollution is another factor, limiting the use of outdoor air, as are thermal comfort and acoustic insulation. Deep interior spaces often make natural ventilation ineffective. At its best, natural ventilation can be highly effective in reducing the risk of aerosol-borne infection, but it is not always feasible or reliable. COVID-19 is airborne. The most common way COVID-19 is transmitted from one person to another is through tiny airborne particles of the virus hanging in the indoor air, whilst or for minutes or hours after an infected person has been there. Other than in specific rooms in hospitals or in healthcare centers, mechanical ventilation is designed for comfort and not for infection control. And most buildings cannot achieve the air changes per hour needed to protect against highly infectious viral aerosols, like the current COVID-19 variants. As we emerge from what has been an almost 3-year indoor air crisis, I'm privileged to talk to you on this online seminar at a time when we have developed the Portascanner AIRTIGHT 520. We need energy efficient ventilation to introduce pure, fresh air to disperse and remove viral particles and to lower the risk of people inhaling them or getting infected through their eyes, nose, or mouth. Using high quality air filters, we can remove 99.97% of human generated viral particles. Energy efficient mechanical ventilation and effective air filtration. Energy efficient mechanical ventilation and effective air filtration must start with an airtight building. Any unwanted air infiltration or leakage through gaps or cracks in the building will adversely affect the integrity of any air filtration or purification process, as well as increasing the energy consumption of the air handling units. By achieving passive house standards of air tightness and creating a building for which thermal comfort and acoustic insulation can be achieved solely by post-heating or post-cooling of the fresh air mass, and which is required to achieve sufficient indoor air quality conditions without the recirculation of stale air, is normally fitted with a mechanical ventilation heat recovery MVHR system. This provides a continuous stream of fresh, filtered air, warm or cool, to suit the needs of the occupants. By taking a fabric-first approach, which delivers phenomenal thermal performance by maximizing air tightness and minimizing thermal bridging, these buildings will typically use 90% less energy and are healthier by being free from humidity, mold, airborne pollutants, dust, allergens, and airborne viruses. In well-ventilated buildings with effective air filtration, the infection rates of COVID-19 have been reduced by as much as 80%. Other benefits of airtight buildings. As mentioned, other benefits of airtight buildings include thermal comfort, acoustic insulation, pest and infestation control, prevention of water ingress, and fire suppression. Maintaining oxygen levels, either to prevent a hypoxic environment for health and well-being, or to create a hypoxic environment to reduce oxidization and to suppress or prevent fire, require these spaces to be kept airtight. With a Portascanner AIRTIGHT 520, buildings fitted with fire suppression systems can now undergo frequent and regular air tightness checks to ensure that the fire suppression systems are effective by preventing the infiltration of oxygen through gaps or cracks in the building. The Portascanner AIRTIGHT 520 complements pressure testing. The Portascanner AIRTIGHT 520 is a micro air leak detector, and as increasing levels of air tightness are finding their way into building codes and practices, this instrument will be critical in enabling any trained operator to be faster, better, and cheaper than their competitors in the detection, rapid location, and in quantifying the airflow rate through each leak site. This has never been achieved before by using ultrasound. Importantly, the instrument does not require the leak sites to be detected in a pressurized environment, and its applications can include regular air tightness checks during the execution of a build program, both in a new build or in a retrofit. Above all, the Portascanner AIRTIGHT 520, when correctly used, brings certainty to passing a pressure test first time, every time, and the cost savings can be enormous for the contractor, for the owner, and the occupier of the building. Applications in modular integrated construction, MIC. In Hong Kong, MIC module suppliers are likely to be in mainland China, where quality control and quality assurance will have to be performed in the factory. Buildings which are designed to be airtight are those which normally have a far higher quality build and technical specification. With the Portascanner AIRTIGHT 520, these precision-made components, such as panels, doors, and windows, can be individually tested for airtightness before they are assembled to produce the volumetric off-site build solution. The Portascanner AIRTIGHT 520 takes our understanding of fluid dynamics at sea and applies it to airflow dynamics on land by using the best ultrasonic technology with a microscopic level of accuracy to detect leak sites as small as those with a diameter of 0.06 millimeters, and to apply computer science to measure and quantify a leak site as small as one with a diameter of 0.5 millimeters by its algorithm, which also generates the airflow rate and the air permeability factor. The ability to record and analyze these leak sites and to export this information makes the Portascanner AIRTIGHT 520 unique and a critical instrument in the production of buildings where MIC is used, where the main contractor will still bear the full contract risk, and where the certainty of the airtightness must be assured before the MIC module leaves the factory. Thank you.
I'll just quickly. So this next slide is just a short video, a few minutes long, of a test with the Portascanner AIRTIGHT on a door in our labs here in Durham. So you just go and press play. Thank you. Sorry, Edmund, we're not getting audio from the video.
Single transducer supported by a truck.
Thank you.
In this demonstration video, Angus shall be using the Portascanner AIRTIGHT to measure the leaks around an ordinary door. Angus is using a Portascanner AIRTIGHT receiver unit with a receiver wand and a small single transducer supported by a tripod stand. Not shown in this video are the headphones and the 3 transducer generator, which may be useful in some applications. To begin the test, Angus presses the full test button and enters in the required information for the structure that he is testing. He then configures the generator with the aid of the tripod stand. The generator is turned on by pressing the on button and placed in an appropriate location, facing the center of the door. The receiver unit is then used to do a quick scan of the door in order to ensure that there is a good coverage of ultrasound. Angus moves the receiver wand around the door's perimeter. He observes the signal indicator to check that the line remains broadly within the green zone. When he is finished, Angus presses done and closes the door. Angus then takes a photograph of the door, ensuring all of its sides are visible. Now, Angus uses the wand to look for leaks in the door's seal. He is looking for spikes in the signal indicator and will mark a leak when he spots it by touching on the relevant part of the photograph. As you can see, the ultrasound can penetrate at this particular part of the door seal. Angus looks for the spot where the red bar reaches its maximum and touches the corresponding part of the photograph on the screen. Angus now positions the wand as close to the point of maximum signal as he can. He presses the measure button and holds the wand as still as possible while the receiver captures data about the leak. Once the measurement is complete, Angus continues to scan the door, marking and measuring any further leaks that he finds. In this case, Angus has found 2 leaks. He presses the Done button and takes a final measurement for each leak to determine the amplitude of ultrasound incident upon the far side of the door. This is called the open air value. The door is opened, the wand is placed in approximately the location that the leak was detected, and the measure button is pressed. Once Angus has done this for both of the leaks detected, the data for the leak location, sizes, flow rates, and air permeability may be saved by pressing the Save button. In this demonstration video, Angus shall be... Okay, thank you very much for watching that video. I hope that gave you a good idea of how the unit is used in practice. Now I'm going to talk a little bit about some of our case studies where we've used the unit in the field. So first of all, we used it at the Airtightness Testing and Measurement Association in the UK. And that was mentioned earlier. And in fact, you saw a report generated from that case study. During that case study, you can see here myself on the left-hand side using the wand to identify leaks within a door seal. And indeed, even though it looks pretty airtight, we did find quite a few leaks along the edge of that door seal, which enabled us to get an idea of why the door fan test was showing more air coming in and out of the building than you might expect. We've also distributed this instrument to a number of different customers. On the right-hand side of the screen, you will see a photograph of a low energy building in Slovenia in Europe. Here, one of our customers was really interested in guaranteeing that a new building that they were constructing was airtight to the extent that it could keep in a good level of thermal energy and therefore would be a very environmentally friendly home. This was tested by a pressurization air exchange method a couple of days before, but the homeowner was really interested in finding those microscopic leaks that had occurred during the construction. Our Portascanner AIRTIGHT was perfect for this, as it enabled the owner to detect where the leaks were, quantify them, and then to perform some remedial actions. For the middle case study and for another case study, I'm going to pass over to Angus again, who's going to talk briefly about those two.
Thank you very much, Daniel, and hello to everybody. So for this case study in the middle, this was a test that we performed with a distributor of ours at a passive house site in Manchester. Passive house, I think Bernard mentioned just a little earlier, is an air tightness standard for the built environment, which is about aiming to achieve net zero in the built environment, doing this in part by being incredibly airtight and similar to the low energy building in Slovenia, keeping in as much thermal energy in the thermal envelope of the building as possible. For a bit of context, the building regulations in the UK, the total combined leakage area for a typical house is roughly the size of a cash machine, an ATM, whereas according to Passive House, the total permitted size area of leakage is roughly equivalent to a credit card. So it's much more stringent than the national regulations. For this trial, I went on site with our distributor to demonstrate the unit to him and show it to him on a passive house build that they had not quite finished yet. And this building could not be tested with a door fan test at this stage. It was missing a door on the back of the house, and not all of the windows had been fitted. And Portascanner, sorry, was perfect for this, as there's no need to pressurize the building. So we tested a party wall. This was a semi-detached house, so there was two buildings separated by a party wall. We tested that party wall. We tested all of the windows that had been installed, and we tested the front door. We found a couple of small leaks in the window, but that was in general pretty good and within their expectations. And the party wall also looked quite good. However, when we tested the door, we found a number of different leak sites in a couple of the corners at the top, but particularly we found really quite substantial leakage at the bottom of the door. And this went across the full extent of that, which indicated to us that there was a crack. When we went back and told the site manager about these results, he confirmed to us that, in fact, the door had only just been put in and had not yet received any final adjustments. And based on the information that we provided them, they knew where to start with that already. Thank you. Next slide, please. And this final case study is something a bit different to all of the rest of them. And this was another distributor of ours, or distributor to be, I should say, allowed us to come and visit them in their facility to test a biological safety cabinet. Specifically, this is a Class 2 biological safety cabinet. So a biological safety cabinet, or a BSC, is a fume hood, which is used to deal with very harmful biological samples, or potentially pathogenic samples, and these kinds of things. And this would be installed in a clean room environment. These, as I say, they contain very harmful chemicals and pathogens, and so often need to be fumigated at regular intervals. During the fumigation, it's very important that the fumigant is contained in the cabinet, so it needs to be able to maintain a certain level of negative pressure. And as this is a structure with an open front when it's in use, so that the users can get their hands into to perform their tests, that this is not something that can be tested using pressurization equipment. In fact, currently, the only way to test this at all is to use an aerosol spray to produce particles and a photometer to detect those through any of the seals. However, this can introduce contaminants into the filter or just into the cabinet itself. So we brought along a Portascanner and we tested the cabinet that you can see on the images here. We tested a few areas of it, the front, the back, the sides, and the top, including a couple of areas that the manufacturer expected to find some leaks. And we absolutely did very quickly. We found leaks in all of these locations. This cabinet was one that had not had final sealing yet, so this was expected. But then, as you can see in image 3, just about, we actually sealed this up, or at least we sealed up 2 of the leak sites that we found using some silicon sealant, and went back and retested. And you can see the difference between image 2 and image 4. Where on image 2 we have the red bar, which indicates a leak has been detected and it's very full. Whereas in image 4, the bar is still green and much lower, which showed that we've immediately improved the quality of the seal. And we can be confident now that area at least is as airtight as it needs to be. Thank you very much.
Thank you for the presentations. So, do you have any question for the speaker? We have received a few already. So maybe I start the Q&A sessions. The first question we received from Eric is, the first question, is the Portascanner suitable to detecting leakage at building envelope, of which one side to facing atmosphere? Can I invite Daniel? Maybe, yeah?
Absolutely. So the answer to that is it absolutely is. Any structure, any area of wall or window or door or whatever can be tested as long as you can place a generator on one side and a receiver on the other. It doesn't matter whether any is whether one side is external to the building or not. In terms of different levels of the building, you can place the generator on the stand that you saw in the video, or indeed dangle it using a rope or some sort of contraption for doing that, so that you can access various levels of a building and not just the ground floor. So it is absolutely possible to do that.
Okay, thank you, Daniel. There's a second question to follow. The question is the system sensitive to environmental noise?
As far as we've tested it, we have never seen any significant interference from environmental noise. The ultrasound is produced at a frequency of around 40 kilohertz, and the receiver is filtered such that only sound waves of a very narrow frequency range around 40 kilohertz will be interpreted by the instrument. So it's at least theoretically possible that you may have another source of that frequency of sound, but it's very, very rare. And we within the operating instructions, we guide users through that process in order to ensure that the environment they're in is suitable and that there are no background noise sources. But as I say, that's never happened in our test, or indeed for any of our customers so far.
Okay, thank you, Daniel. There's another question from Frank Lowe. The question is regarding the Portascanner. Can it be used to replace the door fan test? Does the FSD accept the Portascanner as a tool to have report, and the report can meet whether it can meet the FSD endorsement integrity? So the first part is, can it be used to replace the door fan test?
So I would always recommend, where possible, doing a door fan test in addition to using the Portascanner AIRTIGHT. In cases where it's impractical to do so, the Portascanner AIRTIGHT can fulfill that role. Not only can it locate leaks, but it does provide an air permeability value. So it can in some ways replace it. However, you're always going to be more assured of the safety of the environment if you use a door fan test as well, and I would always recommend doing it. In terms of the second part of the question, the report generated by the Portascanner can be used to generate the necessary data, and I don't know specifically about FSD regulation, but I know a lot of regulation specifies that a pressurization test is necessary, in which case it should always be used complementary to it. But when the Portascanner AIRTIGHT is used as a complementary tool for the door fan test, it ensures that the test goes quicker. It means that you only have to do it once and not repeat it. So it's beneficial in that regard, as well as if you're just using it on its own.
Okay, thank you, Daniel.
Just to very quickly add to that as well, in terms of the Portascanner AIRTIGHT 520 as a replacement for the door fan test, Daniel did mention there are situations where that is still a regulatory requirement. So for new installations of fire systems, for instance, NFPA 2001 and ISO 14520, they state that a door fan test specifically or a pressurization test specifically must be conducted. So in that instance, Portascanner must be complementary, as Daniel said.
Okay, thank you, Angus, for the supplement. Yeah. So another question is from Mr. Lee. The question is, any report can be generated for record after the door leakage test? Daniel? Okay.
Yes, absolutely. I think I'm not sure if I'm interpreting this question correctly, but once you've done the door leakage test, a report will be automatically generated for your tests as long as you press the save button, and that report is exported from the unit via a USB. So you can there's a USB drive in the unit. You place that in, the file will be exported to that, and then you can upload that to your computer system and use that in any way you want. I hope I've answered that correctly. If not, please do let me know. Okay,
thank you, Daniel. Another question from MK Yip. I think the same question, similar question. The question is, can airtightness testing replace door fan test? I think you answered that already. Yeah.
Yeah.
So another question from Eric Chin. The question is, what if the leakage is from the ceiling or small opening from the pipework at a very high level of the wall? Example, over 5 meters or below our raised floor. Can we still test it using this equipment?
The answer is yes, as long as it's practical to reach that section. We do offer extensions to our receiver wand. So you would have seen in the video, the receiver wand was sort of about that large. Well, we offer larger wands which can extend beyond that, several meters. And of course, if you have a step ladder, in some situations, you may need that sort of equipment. And for the right applications, it's possible that we can provide more specialized equipment in order to help you achieve those cases. But in theory, you can absolutely test any area as long as you can have the receiver on one side and the generator on the other.
Okay, similar question from YK List. How to check the leakage inside the false ceiling area? Wall side where not easily to reach by the instrument. The false ceiling, you know.
Yeah. So we offer two different ultrasonic generators. One is a larger one, which is useful for covering a broader area. But you will have seen in the video with Angus, the generator in that video was quite small. It's only about this large, and therefore, in terms of a false ceiling area, you can place that quite easily within the false ceiling. If you remove one of the panels, place the generator in, and then replace the panel, the ultrasound will bounce around inside that false ceiling, and then it will be emitted through any leaks. So as long as you can place something inside the level above the false ceiling, then that is definitely an application that you can use the Portascanner AIRTIGHT for. And indeed, we have had customers use it in that particular application.
Okay, good, thank you. Another question, any limitation on this AirTightness 250?
Yes, so
AirTight 250, yeah.
AirTight, the AirTight 520. Yes, yeah. So the limitations, well, such as length of sensor cable, I think, Angus, you might be able to confirm this, but I think as standard, we offer 2 meters, but also 5 meters. Is
yes, so
right?
we do offer, I believe it's 3 for this. Now 2 or 3 meters is standard, but we can offer longer cables as well if required. I would say in terms of limitations, the main thing with this is, as Daniel's alluded to a couple of times, you just need to have access to both sides of the structure. That's the key thing. You need to be able to get a generator on one side and the receiver on the other. Other than that, there are solutions to pretty much every situation we've been encountered with so far. We've been able to come up with a solution for.
We've been pretty inventive at solving some sort of more complex cases, but it is of course true that in some situations it's going to be very difficult to access both sides of a structure, and that's why we always recommend complementing with the door fan test. But for example, if you're trying to do a high-rise building and you're on the 6th, 7th floor, you need to make sure that you can suspend that generator outside of that building if you're trying to measure the air tightness of that. So you need the right equipment to go alongside this in certain situations. So as a worst case scenario, you will be able to identify leaks in one part of the room or building, which is still very beneficial, because if you spot significant leaks, you can then do remedial action. But if you have the right tools and the right inventiveness, you can survey the entire room and building and therefore get that more complete picture.
Okay. There's another question from what about if the hole caused the leakage is masked behind something or is not exposed, the hole? Can it still be identified, the leakage?
Yes, it can. Now, if the basic physical principle is that if air can get in and out of a building through some route, so can ultrasound. Ultrasound is just like any sound wave. a pressure wave of air particles bumping against each other. So if air can get in and out, that means ultrasound can get in and out. Even if the route is a little bit circuitous, a little bit tortuous, you can still identify that as long as you've got the generator placed in the right position and you're using the wand appropriately. The ultrasound will find its way out through the leak, even if that leak isn't obvious to the eye. So it's very beneficial, both at spotting leaks that you can see with your eye, but also leaks that you would have no idea were there if it weren't for the ultrasonic instrument, the Portascanner AIRTIGHT.
Yeah, I think one very quick example of this was a training call that we did with an American customer, and they were doing some scans and on the room that they were in, and identified a leak that was behind a light switch panel, essentially. So that's an example of exactly that being done with this.
Okay, and the question is from Eric Lee, is when the system is being used for detecting leakage of external building wall, maybe 200 meter high, very high, the source may be put outside the building. Will the detection be affected by the wind blown? That's a
very, yep, thank you. That's a very, very good question. The answer is that ultrasound is affected by wind. It is affected by the movement of air. However, our instrument takes 250 readings when you're quantifying leaks over a period of time. So no matter how the wind is moving, it takes a number of different readings over about maybe 10 or 15 seconds, and then it takes a mean value for those readings. So even if the ultrasound will fluctuate over time, which it always will do under windy conditions, the instrument can still deal with that.
Good. And a question from AYC, the question is, can the equipment differentiate leaking in and leaking out of air? Where in or out, can it differentiate?
The answer is no, it's not designed to do that. So the way the instrument works is it's actually, the building doesn't even have to be pressurized. So even if, actually this is quite a key point, even if there is no air moving in and out at that present moment, the unit will identify if there is a capacity for that air to move in and out, if that space had a pressure differential. So the Portascanner AIRTIGHT spots leaks even when there is no pressure differential. So you can then input into the unit a pressure differential, say 50 pascals, 100 pascals, 10 pascals, and then it will tell you how much air would be likely to flow through that leak if it were pressurized to that condition. But it does not need to be pressurized, and even if there is no air moving in and out, it will still spot the leak.
Okay, good. And the question is how and will the wall thickness affect the accuracy of the result? The wall thickness.
Very good question. It does affect the accuracy of the result, and that is input by the user into the device. So the wall thickness doesn't affect noticeably when you're locating the leak, but when you're quantifying the amount of air that flows through it in a certain amount of time, that is affected by the wall thickness. That's why we ask the user, when they're inputting the structure that they're testing, to measure that wall thickness. And as long as they do so to a reasonable degree of accuracy, then that will yield an accurate measurement. If you're measuring the wall thickness and you put it in as twice as thick as it actually is, of course that's going to affect the accuracy. But if you do so within 1 or 2 millimeters, then that's usually a good thing to do.
Okay, good. Another question. There's still a lot of questions for you, Daniel. Yeah?
Okay, I'll try and be a bit quicker in my responses.
The question is, can any measurement be done on the other side of the room?
Well, you can. It doesn't matter which side you've got the receiver and the generator. I hope I'm answering this right. You can do it from the outside or from the inside.
Oh, that's good. Okay, very good. Another question from Mr. Poon, David Poon. May I know the ultrasonic generator from the equipment, whether it disturbs or has any effect on other medical equipment in the area where we are doing the measurement? Will it affect other medical instruments?
Yeah, Not as far as I know. With regard to medical instruments, the ultrasound, for example, pregnancy scans or tissue scans, those are using ultrasound that is propagated into a solid material, which will be a very different frequency to the ultrasound that we use. Our ultrasound propagates through the air, and upon contact with the surface will reflect off of it. So as far as I know, there's generally no interference with medical instrumentation, although that's not my field of expertise, but from a physics perspective, that I don't see that being an issue.
That's very good, because this is, I think, very important factor, yeah, in measuring medical facility.
Yeah.
Another one of the big advantages of this compared with pressurization tests and any other kind of smoke pencil test, any other kind of test locating leaks, is that it's not disruptive at all. You can do this with people in the room; they wouldn't hear a thing. It would have no adverse effect on the people working or sitting or whatever they want to be doing in that room. You can just set up the generator and the receiver, and no one would ever know you were there unless they saw you. So,
okay, that's good. Thank you, Angus, for the supplement. Yeah. Another question from YKD as well. Have your instrument tested to any international standard or obtained any certificate? Is it acceptable to replace Pandora test in UK by the authority?
Mm-hmm. Yes, so the instrument has standard CE certification, which is the European Union standard. In terms of replacing Dorfan test in the UK by the authorities, that's something we're working with. Obviously, it's a new technology, and it takes time before disruptive technologies are recognized by the regulations. But ultrasound as a potential technology is mentioned, but specifically our development is not specified yet within the UK regulations, but we are working on getting it there. And we've done a number of studies with leading universities in the United Kingdom, and hopefully by the end of, in fact, early next year, we will be in the midst of a study with one of our leading universities in airtightness, and we hope that the results of that will inform government to update the legislation accordingly. And I foresee that in the next few years, ultrasonic technology, in particular the Portascanner AIRTIGHT, will be mandated for this use. That's my ambition. And Bernard, who talked earlier, it believes that too. So we're getting there.
That's good. Looking forward to have the approval from the authority. Yeah. Another question is from another question from KM Log is, can we get the result from the same side with the generator? Yeah. Sometimes the other side is not accessible. I think you answered that because you can measure from both sides. Yeah.
Well, you can measure from both sides, but you do need to have the generator and the receiver on either side. If you can't have any ultrasonic source on the other side, then I'm afraid you'll struggle to get a real measurement there. So I wouldn't recommend it.
Yes. Yeah. Okay. Another question is from WC Low. How likely will the device be interrupted by other medical equipment which also emit ultrasound?
I don't know of any that use airborne ultrasound, so I'm going to say no. But if someone were to say that they were using a medical device that uses 40 kilohertz airborne ultrasound, then that could interrupt it. But I think none that I know of would use that very particular frequency, because it's a very narrow frequency band, and ultrasound can exist in a number of different frequencies. So the likelihood of a medical instrument using the particular frequency we use, I think, is quite low.
Okay. Another question from FK Warren. This is an interesting question. Is this system also suitable for water pipe leakage? Checking welding joint, or to substitute hydraulic pressure test?
Yes, as long as you can get the generator within the pipe.
So it has to be a very big pipe, yeah?
So it would have to be quite a big pipe. If it's, if it was this small, no. If it's this big, yes, would be the answer. You can put the generator within the pipe, and the pipe would act as a waveguide, and the ultrasound would bounce around inside, and then you can just walk along the outside of the pipe using the wand. So it can be useful for that application as long as the generator can be placed inside the pipe.
Okay, that's good. Yeah. And a question from Eric Chin. do we need to complete any training before using this tool like the door fan test?
So there's no mandated training, but we would recommend doing training, and we offer training free of charge. There is material on our YouTube channel, so we have videos of training videos that can be used by customers, and we offer training ourselves. But there is you do not need a certificate in order to use our instruments. The Portascanner AIRTIGHT is fairly intuitive, but our guidance is there for you if you need it.
Okay. And a question from Ben Yun. The question is, normally the test will be carried out under a construction site situation where noisy, with vibration, dusty, etc. Any implication to the accuracy of the result?
That's exactly where we've used the instruments. I've used it on a building site, and it doesn't affect the accuracy to any noticeable degree. Okay,
that's good. And a question from YKD as well. Does the instrument require to be calibrated every year by the factory?
Maybe Angus, you can answer this one. I don't think it's required, although I think we recommend a certain period of calibration.
Yeah, no, absolutely. So we provide it with a 1-year calibration certificate. If that's something that you need for your own records for audits and these kinds of things, then you would have to send it back to us for calibration. It's not mandated, but we do recommend it just to make sure everything's working as it should be for the whole lifetime of the product. But yeah, not a requirement, but we would recommend it.
Okay, thank you, Angus. Another question is, the same as from KM Law, on the same side, please also on the other side is not accessible, such as concrete air duct. I think you have answered that already.
Yeah, that would be a challenge. Yeah. So yeah.
Okay. And a question, the last two questions. Is from CK Share. Any catalog can I get in Google? I think you can ask the Innotec people.
Yeah. Ask Innotec, and they'll provide you.
Or Simon to get the catalog. Yeah.
Yeah, they can provide brochures, technical data sheets, all of that kind of stuff. That is all available for you.
Okay, the last one. Does it need calculation? The calculation regularly to ensure the accuracy, the calibration. I mean calibration.
Yeah, I think we answered this, but just again to confirm, the accuracy will remain. A lot of the flow rates that are calculated on this, they're using theoretical models or theoretical and empirical models, and all that we would want to test is the accuracy of that leak size quantification, but it's not required, just recommended.
Okay, that's good. I have a WhatsApp message. The question, but anyway, you answered already, because the question is who verify the correctness of the unit, whether you have authority. You mentioned that you are undergone a approval process to get the authority to verify. Am I right?
In terms of verification, we did that through the National Physical Laboratory, and that was independent. So whilst we were in communication with the scientists there, it was their own experiment which was able to verify the accuracy of that. So that's been verified in terms of the science and in terms of the practical accuracy of the instrument. And obviously we've also done a number of case studies now, so that we know that it's useful in the field as well, and we will continue to do so more and more. We're doing some with universities, and hopefully get it into government regulation as well.
Okay, thank you, Daniel. I think we have covered all the questions. Thank you, everyone. So, Edmund, you have something to supplement, or if not, thank you everyone for joining us. There's a lot. I think there's a lot of interest in this technology. Definitely, it's a very good technology. Can help us a lot, and we appreciate you all of us for joining this webinar today. For those who require a CPD certificate, we will send it to you after the completion of the. Thank you once again for joining us today, and I welcome you to join our coming webinar in future. Thank you very much. Also, thank you for all the speakers, Daniel, Angus, Simon, and Edmund for your effort. Thank you very much. Thank you.
Thank you all so much for coming in, and thank you, David, for organizing this. Thank you to Innotec for all of your work.
Thank you, Dave. Thank you, everybody. It's been a pleasure.
Yes.
Thank you.
Thank you.
Đấy á,好叻啊，好叻啊，5.3個字啊！我想科嚟寫5.10分啫，我特